we're going to be talking about an experiment that we're running over the course of December and early January to map both the depth of the water and the coastal topography of the test site in lower Tampa Bay. The reason we're doing that is we're trying to figure out exactly where the land and water meet so that we can do better models of how extreme weather and climate change will impact on coastal inundation in the Tampa Bay region. Our study actually involves 3 separate types of platforms to do this work. Going from the top down, we're looking at different satellites that can tell how deep the water is and how high the land is based on radar topography that the satellites generate. The next level down is aircraft level, and we'll be using a fixed wing aircraft with a green laser component called LIDAR, or light imaging and ranging. And LIDAR is an important technology not only to get the height of the built infrastructure above the land, but also in relatively shallow water, you can actually use that green laser to measure how deep the water is. And then the third layer in this cake is the actual use of surface vessels. And so in this case, we're using an autonomous solar-powered surface vessel with a sonar built into it that can sweep relatively wide swaths as it mows the lawn in these Tampa Bay area. And so what we're trying to do is use the 3 technologies in a complementary way. So the LIDAR can only see to certain water depths based on how cloudy the water is, because it's a light-based system. The sonar can see very precisely through even murky water. And so what we're going to do is use the sonar and from the vessels in relatively deep murky water, and the LIDAR in relatively shallow and clear water. The technologies have been around for a while, but they're put together in new ways. So for example, this surface craft that we're using is solar powered. It uses a relatively new type of sonar that allows a fairly wide swath. Never before been put on a solar powered vehicle before. So, basically what we're looking at is a vehicle that's capable of going long distances without refueling. And so that certainly is new. What's really kind of unusual and relatively new is the fact that we're putting these technologies together. We're not doing just a LIDAR survey or just a surface vehicle survey or just a satellite survey. And so looking at the intersections will give us a lot of confidence that we've filled all the holes and we have a good map of the area. And it's really kind of interesting because when you think about the maps that we have of the land, and of course, satellites can see every detail of the land. But when you get to the ocean, much less than half of the world's ocean has been mapped, even to a relatively crude scale. And we often say that we have better maps of Mars than we have of the oceans of the world. And so we're trying to use these technologies to demonstrate how to efficiently and cost effectively gather the kinds of data that we need for all sorts of applications, including coastal inundation, preserving natural resources, mining sand to put up on the beaches for beach renourishment, all those applications where we need good maps. We're trying to come up with efficient ways to do that. One of the things that's important is the Florida legislature and the governor have realized how important these maps are, and they put $100 million into the 2021 budget for the state of Florida. What we hope to do is to work with the people that are managing that money to find the most cost-effective ways to gather the mapping data that we need so that we can combine these technologies in ways that are most efficient. And so hopefully we can help the states sort out how they can get the biggest bang for their buck.